Now moving on to question 30, we're again using a calculator to solve a trigonometric equation. And that equation is this one here. So cosine inverse of negative 0.91 coming off the calculator. So cosine inverse of negative 0.91, whoops, 0.91, 2.7141. So I'm going to call that 2.7141. Again, that's not the only solution. Now 2.7, that's a little bit less than 3.14. So I must be talking about a position over here. And I'm pretty confident in that because the x value is negative over here. Well, the other position where the x value is the same, negative 0.91, would be in this position right here. These two have the same x coordinate. So we know how far this distance is. That's 2.71 radians. I shouldn't call it a distance. We know that that angle measure is 2.71 radians. So this measure is also 2.71 radians, but in the opposite direction. So what I'm going to do to find that position is I'm going to take 2 pi, a full rotation around the unit circle, and subtract 2.71. This will get me back to that position. And I'll know that the other solution is 3.5691. 3.5691. So those two angle measures have now been identified, and when rounded at this point to 2 decimal places as instructed, we see the solutions that are presented by MathXL. For number 31, same sort of thing, except I don't know that we'll need to change secant into cosine this time around. All I need is secant inverse of negative 1.2. And according to my calculator, this is why I like the Inspire so much. It has all of our trig functions readily available to it. Secant inverse of negative 1.2 is 2.5559 radians. 2.5559 radians. And if we're thinking about where this exists on the unit circle, well, maybe there is a benefit to considering the equivalent value here. Secant is the reciprocal of cosine, so we would be talking about 1 divided by negative 1.12 for the x value, for cosine. But also I'm recognizing that cosine, if all students take calculus, cosine is only positive in the first and the fourth quadrant, so therefore if cosine is negative, then we must be talking about an angle measure somewhere here in the second or third quadrant. Now here again, I don't know exactly where this angle is, and that's not really necessary. Well, I do know where this angle is. That's 2.55 radians. But where that lands in the unit circle is not real critical because I've got that value represented here. But to find the other angle measure, well, for cosine, as far as that goes, I can just move to the other side of the unit circle by subtracting this result from 2 pi. So I'm going to do that again. I'll take 2 pi and subtract the answer from the calculator a moment ago. And I'll see that the other angle measure is 3.7273. We'll go with 3.7273. And if we check our solution as presented by MathXL, we see we've got a pretty good match. For number 32, let's subtract 5 and then divide by 3 so that we see that tangent theta is equal to negative 5/3. That means that theta is equal to tangent inverse of negative 5/3. thirds. And according to our calculator, let's see here, tangent inverse of negative 5 over 3 looks like negative 1.0304. Negative 1.0304 when rounded. And again, that's not the only solution inside of our unit circle. In fact, that solution isn't even in our unit circle. This angle measure, negative 1.03, is talking about a clockwise rotation to a position, and negative 1.3 doesn't even exist inside this unit circle. So we're going to have to fix that. So if I'm talking about this position in the unit circle, but it was given to me as negative 1.03, then I need to add to it 2 pi radians, an additional rotation to get this pointer, to get this angle measure lined up in the same spot. So I'm going to do that first. I'm going to take this previous answer and add to it 2 pi so that I have an additional rotation. There we go. So one solution is 5.2528 radians. That would be better than this one. We'll call this one 5.2528. Now, the other angle measure that also contains a negative tangent result is going to be over here somewhere, the half circle opposite of that. So now that I have 5.2528, I'll go ahead and subtract 1 pi, or half of a circle, from it. And this gives me the other angle measure on the opposite side of the circle, 2.1112. So I like this, and 2.1112. This solution and this solution. If we check against our answer key, yep, I think we got them. So be real careful there. I know the calculator gave us this result of negative 1.03, but that number doesn't exist in the domain specified by MathXL. So we've got to be sure to put our solution, even though it represents the same position, we've got to put our solution in that original initial unit circle. And we'll finish out this video with one more problem like that. Add 5 to both sides and divide by 6 in order to get the trig function by itself. So we now see that cosine theta is equal to 5/6, not a number that we're familiar with in our unit circle, so we'll use a calculator. Theta would be equal to cosine inverse of 5/6, and cosine inverse of 5/6 is equal to 0.5857. 0.5857. So there's one solution, and that one does sit inside of our unit circle. Speaking of the unit circle, 0.58 radians, well, that's somewhere over here. When does our x value equal 5/6? Well, that's here, but it would also be down in this position as well. This angle down here produces an x coordinate of 5/6. And so to obtain that position, we could rotate all the way around the circle, but we already know what this angle measure is. That angle measure would be equivalent to this angle measure. So I'll just take my full unit circle and subtract this angle measure to find that position, just like we've done with cosine in the past. So 2 pi minus the prior angle that we just calculated, and that last position is 5.6975 radians. 5.6975. 5.6975 radians. And if we check our solution, now round it to 2 decimal places against the answer key, I think we've got it. All right, hopefully one more video will wrap this up. The final questions get to be kind of interesting because now quadratic format for trig functions are involved, but we can handle those. So make sure you check in.